It's very late in the afternoon and I hope that everyone belum ngantuk sama hari ini. Saya sudah ngantuk soalnya. Before I begin, let me introduce myself. My name is Avinanta Tarigan, as you can see in the slide. And sorry. Yeah. I'm with Gunawan University. I'm a lecturer in Computer Science Department. I am also the head of Center for Information Security Research, Cryptography and System Security Research. As you can see, that my research interest is in the formal methods, PKI, crypto, and distributed and decentralized system. And I also developed some software projects. In 2000, I developed the certification authority system, CA system for PT Telecom, and also some other projects. For example, the OTT platform, ABTV, and so on and so forth. So I'm very well known with the software development process and life cycle. Okay, my motivation here. I don't think that I can post the statistic of the how vulnerability in software development, in software growth, and for I can see every day. I get acquainted with a group of hackers. They are from junior and junior high school and high school. So each one of them discover on average 2 vulnerabilities per day in their spare time. So you can see how many vulnerability growth in our applications, in web application or in mobile applications. There's so many of them, and many applications is sitting like are sitting duck and waiting to be exploited. And security awareness is slow. Yeah. With the IT people, you know that the security awareness among them is still very low. And what disappointed me is the building secure software not in programmer competency matrix actually. So you can, if you know the SKKNI, Standard Competency Nasional Indonesia, one of them is 615 tahun 2012, 2012. Tidak ada di situ yang bilang bahwa seorang programmer harus mengetahui bagaimana caranya untuk mendevelop secure software. Ya. Nah, okay. So let's see how the traditional approach works, how they can build the secure software. They start with the risk analysis. They identify the assets, they identify the objectives, and they do the risk analysis. Sometimes they use the attack tree, if you know attack tree, and misuse case. And then they design the security design review, in which you define security methods that have to be implemented in the software, and you review that, right? And then after coding, you have to hire security expert or bug tracker to come down, look throughout your code, and say, oh, this is the bugs, this security related bugs that you have to fix it. After the test and get integrated, then the last one is the penetration testing. Penetration testing actually test the whole system, not only the software, but also the operating system, the middleware, open ports, and so on and so forth, and make sure that your system is secure. And then you go into production. In between, you can have a team audit whatever you done in this, throughout the process, and the team will say that the process is good, then you are secure. In many ways, they are also they do the security testing at the end of the process. I mean, when this is completed, go to the production, they test it in the end. This means that if there are vulnerabilities they're discovered in the end of the process, then you have a very costly correcting it, right? It's very costly because we have to go to the start and start from the beginning, look after your code, and so on and so forth. Yeah. And then comes the modern development method. You call it the agility, right? Because the business demands requires constant change. You need to change your software every day. Yeah. And then the DevOps, which is continuous delivery of releases. Yeah. It promotes agility, but sometimes the demand of the business is too high that you have to deploy before release. The development of Windows is very small. For example, Amazon, they deploy every 12 seconds. You can imagine how fast it is. And how can the security be, how can we ensure that the system is met the security standard, that the system is secure? That is the problem here. So you can see I picked some funny picture that the from Cheslog to 2014, it means that everything that comes from the software is a security problem. Yes. That's why the problem is that they deploy it too fast. They cannot get all the security process like risk analysis and so on and so forth in this kind of development methods. And the testing is usually limited to a functional test, how the software perform as it is specified before. Okay. Sorry. So the approach is you have security in team. It means that you have one guy or two guys that are expert in security in the team, and they define the security approach. How can you develop the software securely? They guard the entire process until the releases. And everyone should aware the risk of being agile, and the risk of the application itself, of how it operates, and also the various security threats. They are known to them. Sorry. And they have the security as part of everything. You know, the chain of trust. So security is like a chain of trust, and every single chain matters here. One chain is broken, then the whole security is broken. So it's important to know that security is part of routine. And then you comply to a security model that chosen from start. For example, we use multi-level security. They have you to comply with this security model chosen and stick to it. And then I And here, security testing is automated. You cannot have someone who look after the codes 2 days or 3 days before getting released, because the business demands is too high, and so on and so forth. So why security testing is hard? It is not like the functional test. Functional test means if I give input out to the software or the program, it has to output B. Functional testing is to verify that the software meets the specification. What if the input A produced also resulted in C? This is the side effect that the security is concerning. It tests your system against known vulnerabilities, but how about unknown vulnerability? It's like if you have antivirus, the antivirus can recognize the virus that they have in the database, known virus. But how about the unknown virus, right? So the focus here is to find new technique in the research to find new bugs and new vulnerability. So in security testing, there are two approaches. One is the functional testing for security. It means that you define the security requirement and you want to test it, whether the code complies well with the security requirements. For example, that. Do you find the code is okay? Where is the bug? You can see that the default is admin. So every input of user rights other than 3, 2, and 1 becoming admin. And then the security testing, it tests against unexpected behavior or side effect. Can everyone tell what's wrong with this code? Yeah, the array is only 8. And the input user variable can override it because you want with the CI, right? And you create the security problem because it overrides the admin privilege from 1 in default to 0, and so on, or from 0 to 1. Types of security analysis in the code. There are two types of security analysis. Static analysis, it's just a white box. So you verify the software, the codes, without executing the software itself. So you need the source code, and you analyze it, whether it's manually or using the tools. Code inspection, it's also a static analysis. A dynamic analysis, on the other hand, is a black box testing. So you verify the software by executing the software, using specific inputs, and checking the result of the software itself. This is what pen test scanner and web application scanners do. And then you can have both of them, which is a hybrid analysis. Okay. In static analysis, of course, you need source code. Right. Some of them can operate on a bytecode, not an executable code, because on the executable code you have to decompile it first, and then it's hard to do it. So it provides much more context because you can examine variables, how variables is changed over the state transition, time stream, and so on and so forth. And if you find the problem, you can directly fix it, right? You open the source code, you analyze it, and you have to find the bugs, and you can directly fix it. The cons, sometimes you have difficulty to have source code for proprietary software, of course. So you have to rely on the security of that software. And of course, dynamic linking library cannot be analyzed because it's already in executable. Yeah. The dynamic analysis, you can check every possible state of the system in code, in theory, and you can know that there is a bug or there are not a bug. There isn't. Useful when source code is not present, of course. The problem is you can miss important information because you don't have the source code. And there are problems that we'll address later, that state space explosion problem, because you cannot check all possible input here. In static analysis, there are some techniques to do the analysis. First is the control flow analysis. So you collect runtime information about data while in a static state, so in the source code itself. And you can identify the danger sequence. For example, you double free variable, or another example that you have create some initiate object, and then you create another object to do the same thing. You can do it with the control flow graph. Yeah, the abstract graph representation of the software that use nodes and edge to specific basic blocks. You can trace down how the variable is used, and when variable is tainted, you can with a user controllable input, and you can follow them to possible variable function, or we can call sync. Yeah. This is the typical architecture of static analyzer. It's actually works like a compiler. So you have a parser, you have extractor, you have analysis, lexical analyzer, and it compiled, and there are user rules that you can input there, and then it analyzes against the rules. When it is some state against the rules, they can report that this is a bug there. Some static analysis tools that are available, some of those as arrays. For PHP, CVB check. For C++, for those of you who are using .NET, you can grab the crowded. The famous OLAP's Lab C++ for Java, DevBug for PHP, Flow Finder, PMD. It uses pattern matching to analyze its code, and find bugs. Actually, the static analysis for functional tests, but it has the plugin called Find Secure Bugs, Find Sec Bugs, that able to find potential vulnerability in this code. And then also the check marks that support many languages. So you have a Python there, the Ruby if you use the Ruby, and Google source code. You can check for performance report for these tools in URL provided below there. Okay. So in static analysis tools, it could find syntax attack. For example, SQL injection, command injection. and buffer overflow. Yeah. This is a very common attack that can be found, or it can be found by static analysis tools, and also attack that using known tools. This is related to input, malform input, and memory handling. Static analysis is good for enforcing proper secure coding practices to the programmer, because when it is this is the vulnerability, then the programmer tend to learn and to learn that this is an unsecure code. Then they can learn how to program in secure way. However, it is difficult to find vulnerability that can be exploited by the advanced attack. Yeah, it's different level. It can find relatively small percent of vulnerability, but these tools are getting better. For example, Flow Finder, it is a C++ static analysis tools. I tested against 4 libSSL, and it can find number of it, 1,000 to 2,000 potential bugs in every library. Dynamic analysis. So dynamic analysis, performance analysis by executing the code. The issue in dynamic analysis is state expression problem. What is a state expression problem? State space expression problem. For example, I want to test this function. There are 2 parameters, A and B, and actually return A plus B. How many input space do I have to use that make sure that this function performs well? Yeah, 2 powered by 128, and this is a lot. Yeah, this for example, this is an example why dynamic analysis is a problem in state space expression problem. So it is almost impossible to check every state given possible input. What we do is we can randomize the input, and we can also make the input malformed, so we can observe the behavior of the program itself. So dynamic analysis can show that vulnerability exists, but it cannot show you its absence. That's the most important part. Okay? I repeat, dynamic analysis can show you that a vulnerability exists, but it cannot show you its absence. Okay? Because why? Because you cannot check every possible input in it. Okay. Security requirement tests. For example, you in security requirement tests, you test not only what should the program behave, but what should not the program behave. Yeah, for example, login without the right password. You can test your program, update data without the right permission, or get connected using invalid certificate. This is the kind of input that we want to give into the program or the software to be able to observe how the program will behave. Yeah. It can be derived from the attack tree and use case, which we done before during the design process. And advanced tools test these standard tests. Web application security testing tools is example of the dynamic analysis tools. For example, here I use our ZAP very often. It acting like a proxy. So your user use the browser, ZAP as a proxy, and between browser and application. And when you log in and from the applications, the ZAP will remember and checking every possible HTTP request using forms, including login and credentials. And then it can simulate log user, and it can test the application by sending a tag-like and random data into the application itself. It tests also the standard web vulnerabilities like SQL injections, XSS, and so on and so forth. Yeah. So it's very useful tools. This is the user interface of the OAuth. Very handy, very easy to operate, and I recommend it very well. Other tools, OAuth ZAP is open source. Iron Wasps. There's also WebPT, W3AF. Proprietary, we have a Burp Suite Pro, HP Web Inspect, IBM AppScan, and so on and so forth. There are also online scanner that we can use as a pen test in application. For example, like a Phonetics Web Inspector. You don't have to buy the software, but you can run software as a service here. There are also the interesting tests called the fast testing. Yeah. It is testing technique that generate large amount of randomly malformed input, and we use it to monitor the application. So we program as a parameter the application, and we monitor the application against crashes, memory leaks, and fails code accession, for example. So it is good for finding stack overflow, heap overflow, user after free, general memory handling failure. Sometimes it can find bugs that are not related to security stuff. One project called Fuzzing Project, they gather all the tools all together and provide the information to the user how to do the fuzz technique. This is the example of one of the fuzz testing. It's called American Fuzzy Loop. It has a lot of bugs found with this test in widely used software. For example, the Nginx, PHP, Firefox, even in OpenBSD kernel. So it's very handy for a very small program actually. So the limitation of the fuzz testing is some insecure states are unlikely to be hit randomly because they create the random input, right? So there might be some insecure state they are not reachable by hitting that by randomly, and it covers small part of the program. You cannot do the fuzz testing in the very large program. So it fits perfectly for unit testing. The input generation technique has to be improved. So it creates the normal distribution, like Gaussian distribution for all possible data, and to improve it for better hit. So the fuzz testing can be used at the unit security tests, actually. So, the last part is penetration testing tools. After you deploy your applications, and that you know that application is part of the larger system, they are operating system, there are libraries, web servers, database configuration that might have the vulnerability, you can have the pen test tools to test the security of the whole software system. The number of tools available that are very nice to use is Nessus. Nessus once is a open source project, but now it's commercial, very expensive. There are also Metasploit, which is also the open source. You can use a Burp Suite or Acunetics also for as a software as a service. And as you know, the pen test is to be invoked after deployment or release, or you can do it while your system in operation. So you do the security test that is performed in operation manner. So what we have here, if we do this, the whole software life agility, you start a plan, you code, you use the static analyzer. After build, in functional tests, you can use the fast testing for unit testing. You can use the dynamic analyzer to test the whole software that you built. And when you deploy, you can use the pen test tools before the release and operate. The quality of security testing. If you use the security testing tools, then you have an expectation that the tools may found the vulnerability in your software. But the reality is not nice. There are some parameters that we have to measure first. There are two parameters or two variables that we have to make sure that the test tools is okay. First one is false positive. False positive happens when something is identified as vulnerability, but it isn't actually. So it is false positive. False negative means the tester missed vulnerability. Right? When false positive happens a lot, frequently happen, you started to not to trust the tools. Right? Well, this tools is not okay for me because it frequently find vulnerability that actually is not. The false negative, when it happens frequently, then you let the production system in vulnerable state. It creates some that the production system is secure, but it is not actually. It could expose the system to attack. Where there's a false negative, it depends on the test quality of the tools. Perhaps attack was not properly created, or the result is not properly analyzed. There are also coverage problem. For example, in ZAP or in the web vulnerability scanner, the automatic scrolling problems creates not all links in the web application is not valid or identified. There are also new vulnerability, for example, that cannot be identified by the tools at the time. Or there are new variant. It's like your antivirus. If there is a new virus, then your software is not updated, then it cannot recognize or find the new virus. Or the new virus have a variant of it, then it cannot recognize it. Okay. False positive. It against test quality of the tools. For example, parameter if poorly defined, and then the tools is becoming for too sensitive. So everything it found it's suspect of vulnerability, right? For example, hitting honeypots. You know honeypots? A system that you installed in the middle of your system, and it opens many ports, and it actually detects any attack that from the system. Or the patch is available for a specific vulnerability. Okay, 5 minutes more. If you want to use the automatic analysis tools, I suggest you to go to the OWASP benchmark for security automation here. It is the new project by OWASP. It is an open test suite designed for evaluate the testing tools. You can find which security testing tools that fits your needs. There are also report by web application vulnerability scanners benchmark. You can see in the, but this is 2014. This is not new. We need the updated version for it. I myself testing also some of the tools, but it's not finished yet. Some of the tools in commercial, there is commercial is too pricey to get. So I haven't got to publish it. Okay, conclusion. We can use automatic security tools in agile development process. In coding, you have static analysis tools that test your code against vulnerability. You have fast test tools that if it fits perfectly in the unit tests, and dynamic analysis tools when you build, integrate. After integrate tests, you can use the dynamic tools to test your software, and when the system is deployed, you can use also the pen test tools. But you have to define, you have to understand the limitation of these tools, right? That I give you. So you can, when you understand the limitation, then you might want to deliver more than expected. And the quality of tester should be taken into account first. And I quote some of the quote, some nice quote here. Security is a process, not a product. It's by Bruce Nair. That means that it's the whole process that makes your system secure. It's not only the product of testing tools itself. Thank you very much. Oh ya, Q&A. Ada yang mau bertanya, Bapak Ibu sekalian? Silakan, Pak. Yeah, security is a process, not a product. So you want to embed security in the process itself. You can do it by risk analysis in the design process and so on and so forth. There are also tools that I explained before here. You can use the static analysis tools to review your code. But static analysis tools has a limitation, right? You have to understand the limitation of static analysis tools and the quality of the tester itself. And you might have the fast test tools for your unit testing. After you deploy it, you can use dynamic analysis for this. So there are tools that are available that you can you can utilize it in the right phase of your development process, right? Other than risk analysis and so on and so forth.
So basically, my question is, when you want to put the pen test tool in the deployment process, that means
Yes.
every time we continuously deploy that, we want to automatically test that. So is that a manual process or is it automated by a tool?
Yeah, it is automated by a tool. When you do the test manually, then you have problems with the experience with the time.
Hook in your CI or?
Not all of the CI provide the tools itself, but you can manually invoke the tools after you get the release and so on. Yeah. Okay. Any other questions or discussion? Perhaps some experience that you have with the automated security tools? Bapak Ibu, monggo loh. Saya ingin tahu, ada yang sudah pakai security testing tools? Bapak, yang digunakan apa Pak? Berarti di pen test toolsnya ya? Setelah deploy. Context delivery ya. Kebanyakan mereka menggunakan pen test tools setelah deploy. Padahal kita bisa menggunakan static analyzer, kemudian kita bisa menggunakan dynamic analyzer pada waktu kita melakukan coding dan juga waktu kita melakukan build. Dan itu akan lebih baik. Kenapa? Karena setelah rilis, setelah di deploy, begitu di pen test ada vulnerability, Anda harus balik lagi ke awal. Kenapa ada tools? Karena jauh lebih murah daripada Anda harus meng-hire seseorang datang untuk mereview code Anda. Ya. Per jam minta berapa mereka itu? Ya. Silakan Pak. One more questions.
Saya Irwan dari Cinema X1.
Ya.
Ini masalah security untuk di source code. Kadang-kadang kalau ada bug untuk source code yang saya contoh umpamanya PHP di PHP 6 mungkin source code coding ini masih belum bugs, tapi pada saat ditemukan dia melakukan update, ya untuk melakukan security test itu biasanya tools yang mendeteksi itu belum tersedia dan itu ditemukan sama bukan tools tapi orang yang menemukan bug tersebut. Nah itu proses untuk tes itu setelah production untuk mengetahui itu menghindari itu seperti apa itu. Kalau kita tidak harus meng-hire, maksudnya kita tidak harus meng-hire orang yang, maksudnya kita mengandalkan tools.
Ya.
Sedangkan banyak kejadian itu tools itu kejadian dulu baru tools itu
Dibuat.
Ya,
Oke.
jadi harus ada aktif di forum atau di mana untuk.
Ya kalau saya bisa sarankan bahwa bisa menggunakan testing tools yang ada tadi. Kalau mahal bisa mulai dari open source. Ya, tapi belum semuanya tercover. Ya. Ya. Memang itu tadi, kalau kita menggunakan testing tools kita harus tahu limitasinya. Berarti kalau ada vulnerability yang belum masuk dalam testing tools tersebut, berarti kita harus aware hal tersebut. Dengan demikian Anda harus masuk ke dalam komunitas keamanan untuk mengetahui hal terbaru. Nggak usah jauh-jauh di Facebook ada, Anda tinggal lihat di situ, join, kemudian nanti ada beberapa vulnerability yang berkaitan dengan development proses yang digunakan. Anda bisa mentes atau mencarinya dari vulnerability tersebut. Betul. Iya. Iya, nggak bisa diam saja. Ini jadi testing tools it helps, but it has limitation. Betul. Oke, kelihatannya sudah selesai session ini. Terima kasih Bapak Ibu sekalian. Wassalamualaikum warahmatullahi wabarakatuh.